What's up guys, Van Zeven here again with your 5th tutorial on 2D Java game development. We've been progressing very, I think it's pretty good so far. So today we're going to be working on the optimizing the rendering system, and we're going to fix up the how much data we have backing the actual system, because right now there's too much. The color data is very inefficient. And essentially, instead of having these 4 sets of colors, we're going to like 4 recorded sets of colors for each tile. We're just going to put it into one big long integer that we can then parse out and parse to, so we can find out what the color actually is. And we're also going to optimize this rendering system here a bit, because this is pretty inefficient. Well, it's not inefficient, but it's just not it's not very nice. So that's what we're going to do today. We're going to, first things first though, I want to fix the input handler. Everything is good, but I would like this to also accept up, down, left, right arrow keys. So we're just going to do that quickly because that's not too hard. VK underscore up and up, down, left, right, down, oops, left, and right. That's just so that we can test a lot easier, and this will do either or, so that's good. Anyway, it's back to what we're doing. So what we're going to need to do is, right now we have in the screen class, let's just move this over here. In the screen class we have an array of integers, and each set of 4, as you see here, there's 4 different numbers in a sequence, and those 4 numbers are the 4 different color bits for what we need for these 4 colors corresponding to them. So we're going to change that right now. We're going to get rid of this, and we're going to save it, because we don't need that in the screen. That's not part of this. Like, it is part of the screen, but it's not something that we need in the screen. And we'll ignore the warnings for now. We're going to go into the game class first, and we're going to create the array list here for now. We can always move it back if we feel like it later, but we're just going to have an integer right now, and we're going to decide right now that we're only going to have 6 bits of color, like six different shades for each color. We don't want to get overloaded with colors and stuff like that. We only want to handle so much, so we're only going to allow for 6 different shades of each color. So like here to like here, or here to here, I guess. Six different shades here to here, kind of. So that's what we're going to do now, and since there's only going to be 6 different shades for the 3 different colors, we're going to have an integer of size 6 times 6, or 6 times 6 times 6, because RGB. So 6 times 6 times 6 is, I think it's 216. So that's how big this array is going to be, 216. Or we'll actually just put 6 times 6 times 6 in here, so that we know, just so that we know what this represents. Next, what we're going to do is we're going to populate that. We're going to populate this this array with the actual colors. So we're going to do that in the init method, and we're going to have an index here, so an index variable of 0. Now we're going to loop through all the R different colors. So int R equals 0, R is less than 6, R++, and we're going to duplicate that twice and put the ending quotations there, and this is going to be G, and this will be B, and G, G, B, B. So this is going to loop through, it's going to loop through the reds, the greens, and then the blues, and inside here we're going to say colors at index plus is equal to red, and we're going to shift it left 16. Oops, what did I say? Red. Actually, no, we do need a red. We're going to need a red because this would only be a 6. It wouldn't be the actual red color. So the red is going to be equal to that number that we did last time, where it was red times 255 divided by 5. That number. We only want to use 255 because 256, the actual number 256, is we're going to use that for we'll use 255, not 256. We'll use 255 for an invisible color, so that this color will be transparent. That's the word. Anyways, so we'll copy this down twice. We'll have green and green and blue and green and blue. So these are going to give us our numbers from 0 to 5, or like not our numbers from 0 to 5. It's going to give us our shades, 0 to 5. Okay, so now we need the colors at the index plus plus, and it's going to be equal. Okay, now here comes the not too complicated but semi-complicated part. It's going to have to be RR, and we're going to shift it 16, and then or green green, and we're going to shift it over 8, or blue blue, and we're just not going to shift blue. The reason for this is because there's going to be 2 to the 8 bits of data for blue, 2 to the 8 for green, and then 2 to the 8 for red. So it's going to like, yeah, that's how that's going to look. That's why it's shifting it over 8 each time, and this OR again is like the AND symbol, and it's kind of like these, where it's applying the operation straight to the actual bit. You can check one of the previous videos for a further explanation on how that works. But right there, that's going to populate our colors thing. So every time our colors array. So every time this goes, we can just call colors at an index, and it'll return an actual color for us. So there's that. 255. I also should mention. I did a couple of minutes ago as well, but 255 is going to be the transparent color. So if we need a color not to be rendered, so say we want to use, see if we go to the sprite sheet, and we did this last time, but we don't want to see the white, so we want to see through the white, we'll put a 255, and that'll register it here. Next, what we're going to need is we're going to need a color object to parse some of this data to give us this index number. So that's what we're going to do now. So we're going to go into the graphics class. We're going to create a new class called color. You can spell it however you want. Actually, we might as well, since there's a Java class called color, we're going to call this one colors, just to differentiate the two. Now we're going to make a public static method. It's going to return an int, because this is going to be that super long int right here. That's all the data from the 4 different colors. So right now we're converting these 4 into one long int. So how we're going to do that is we're going to need to accept those colors and what we want for each of these colors. So we'll have an int, and this is going to be, we'll just call it color 1, color 2, color 3, and color 4, and int, 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 and we'll return -1 for now. So this is going to have the 4 colors. So this is going to be the darkest color, this is going to be lighter, lighter, and this is going to be the white color, the lightest. So there's that. Next, what we're going to do is we're going to have to return an actual value here, because we don't just want to return -1. I just wanted to get rid of the warnings. And what we're going to return here is we're going to return a get. Actually, I should put a bracket around all this as well. A get at color 4, and we're going to shift this one over 24, and I'll explain why the 24 in a minute. And then we're going to do a plus. Actually, I should probably put a bracket around these instead. Plus a get at color 3, and we're going to shift this one over 16. Yes, 16. Plus get at color 2, and we're going to shift this one over 8, and plus get at color 1. And that's gonna, we haven't made this get method yet, so we'll make this right now. Create method get int. Okay, we'll leave that like that for now. But what this is going to do is, as with the game class, how we're shifting things over 16 and 8, we're doing the same thing here, but instead we're just going to add to these ones. So it's going to return one long number instead of like an actual hexadecimal number, so to speak, an equivalent of a hexadecimal number. This will return one long number with 2 to the 8 bits for the actual lightest color, 2 to the 8 bits for each different color like that. So now we're going to actually we're going to parse out a value right now, because these are going to have to be 4 different values. And what these values are, these values are going to be a number from 0 to 5, because there's 6 bits of data here. So it's going to be 0 to 5 in 3 sequence, so a red, green, blue. So it's, for example, we'll be able to call this color class like this, colors.get, and we'll be able to say like 555 for white, or 000 for black, or like 505 for full white, 1 black, green, and full blue, which is equivalent to this. So it'd be a full white, 1 black, green, and a full blue, which turns out to this color, and etc., etc., etc. So that's how that would work. And this would be the darkest color, the slightly darker but lighter color, the even lighter color, and then the white color again. So that's how that works. So now what we need is we need to return the value from that 0 to 255, or that 0 to 5 inside that array. We need to parse those out. So we're going to say the int, first actually we're going to do an if color is greater than 0, then we're going to say return 255. Sorry, if 0 is greater than color, return 255. Now what this is going to do is this is going to say if we send in a -1 in here, so if we did that color.get, or colors.get, and we did a -1, that means that that color is now invisible. This is not going to get rendered now. So that's how that's going to work. And then we'll do that right off the bat, and then we're going to have an int red, and that's going to be equal to color divided by 100, because we want to get the first part of that. So I'll just create it down here. We'll say, I don't know, static colors.get, and I don't know, 555 53. Yeah, we'll just do something like this. So we want to get this first bit of data here, which is we got to divide it by 100, and then we're going to percent it by 10, and we're just going to percent it by 10 to make sure that it's in between 0 and 10. We could also do a 6, but in this instance a 6 would get it a little wonky. It could become a strange number since 6 is divisible by so many things, but we just want to get it 10 just because we just want it to be in between the scale. And then we'll also do a green and a blue here, green and a blue, and this is going to be divided by 10, and this won't be divided at all. And then what we're going to do is we're going to return r times 36, and then plus green times 6 plus blue. And we're doing 6 again because there's 6 parts of data for each different thing, so we're going to return those into here. Technically 6, there's a 0 as well. And that's that function. So this is how that's going to work. So we can now reference our colors in our screen class. Instead of having these colors up here, we can reference it with this color class now. Next up, what we're going to do is we're going to fix up this render method here, because this render method isn't really nice and pretty. So first off, this tiles will also get removed. We're not going to use it in this one. The tiles will be moved into the actual level class when we do that next episode probably. So first we're going to have a public int, and this is going to be the pixel data. And we're just going to store this in here as well. We'll remove these colors here. Okay, so we're going to say pixels, sorry, not pixel, is equal to new int and width times height. Just to make this the same as this one over here. The same pixel data as this. Just to make it the same size. Now, what we're going to do is we're going to go down here. We're going to leave this method here, but we're not going to use this method right now. We're going to write a new method that's based off of this. So this method is going to be called public void render. Okay, and then it's not going to accept any arguments, or it is going to accept arguments. It's not going to have a return type. It's going to be like this one. It's going to accept an x position, a y position, a tile index, and then an int and a color. And this color is going to be one of these, so we're going to send in this color to this class. So it's going to be that super long int. So that's what that's going to accept. The tile index here is going to be the actual tile index on this sheet. So how we're going to get that right now, because that's going to be, actually we need to multiply by the offset first. So we're going to say x post negative equals to x offset, and same with the y. Just to keep it in the bounds. We don't need to worry about that much, but that's just to keep it kind of like this stuff right here. It's kind of the same thing. Okay, so now that we have this, we're going to actually get the tile indexes. And the tilings that index are going to be referenced off of this, but we need the x and y coordinates of it. And since this sheet is 32 pixels wide by 32 pixels, or 32 tiles wide by 32 tiles high, which is similarly what we kind of did here. That's kind of how we got these numbers here, the y min and y max. What we're going to do is we're just going to we're going to get a static number for each different, not a static number, we're going to get an individual number, a unique number for each different tile. So this tile is going to be a tile 0, this is going to be 1, this is going to be 32, and this will be 33. So how we're going to do that is we're going to do a percent 32 to get the width. So the number will always be between 0 and 32, so we know how wide, like where on the x coordinate it is. And then for the y, we're just going to divide by 32, and we're going to divide by 32 because each different width is percented 32. So since there's only 32 tiles here, the 32nd tile must be a 1, which means that we're here. So this would be a 1, 0 coordinate because yeah, you should get it. I don't need to go that simple for you guys, but that's how that works. So int x tile equals x posts percent 32, because again that'll give us the position on the x. Oops, why did I call it time? Y tile is equal to y posts. Oh no, sorry, not x posts. This is gonna be tile. And this is gonna be divided by 32, so that we know how high it is. That's going to give us the x and y coordinates. Now we're going to need that offset variable that we have up here. It's kind of like the index, but it's more like the sheet pixel. The tile offset is going to give us the actual offset on this pixel data. So it's this right here. So how we're going to get that is we're going to do int tile index is equal to, actually not index, tile offset. It is technically an offset, so we'll call it offset. Is equal to, it's going to be equal to the x tile, and we're going to shift it over 3 because 2 to the 3 is 8. So it's going to, since each tile is 8 pixels, we got to shift it over 8, and it's going to be plus y tile y tile, and shift that over 3 as well. So that'll give us the tile offset. Actually, we need to times by the width as well. Times by sheet dot width. That will give us the same offset value that we have here, kind of. Next, what we need to do is we need to do a loop, because now we need to actually write the data inside those tiles. So we're going to say for int y is equal to 0, y is less than 8, y plus plus, because each tile again is 8 pixels. And we'll close those, and then it's going to be 8, or x is less than 0, or x is less than 8. Man, I cannot talk today. I don't know what it is, but I just can't. X is less than 8, etc., etc. And then what we're going to have is we're just going to put a variable in here that we will alter later, but we're going to just use this for now. We're going to call it int y sheet is equal to y, and down here int x sheet is equal to x. We will change these variables later on depending on how we're manipulating the actual tile, but that's what we're just going to do for now. We also need to verify that the position will be within the boards of the actual screen. So if y plus yp, sorry, y posts is less than 0, because it's less than the screen width, or y plus y posts is greater than or equal to the height, then we're just going to continue. We're not going to worry about that tile because that tile's already past where we should be. We're going to copy this down as well into the x. We can actually move that up one just for performance things, and we'll switch all this information with x's and width. So now that we've verified that we are within the bounds of the actual screen, so we're good to draw. Next, what we're going to do is we're going to get the actual color. So col equals, and this is going to get a little confusing. But what we need to do first is we need to get this actual color data here. Okay, and then we're going to need to shift back or forth depending on where we are in these 4 colors, which one we're actually doing, and where on the pixel that we're doing it. So what we need to do is we need to color, and we need to shift it by sheet dot pixels, and this is going to be x sheet. This is where that was coming in earlier, plus y sheet times sheet dot width plus tile offset. And then we go outside here, and we're going to multiply it by 8, because the tile is 8 wide, and then we're going to verify that it's between 0 and 255, just like it was in here. We're going to verify that we're within the bounds of the colors. So we're going to and 255 it. And actually that doesn't go there. This goes here because we want to and 255 the whole thing, not just the color. So that's going to give us the color data for where on this tile we are. So it'll give us 0, 1, 2, 3, or 4, and then multiply that by 255. So it'll give us the corresponding color in this right here, this color array. Okay, so now we actually just need to set that data. So if the color is less than 255, because we want to verify again that it's not that transparent color, then we're just going to say pixels at x plus x posts, and then plus y posts times the width is equal to col. That's going to set the pixel data up top. So now we have our render method, and that's complete right now, so we can actually remove this one because it's not necessary anymore. And you'll notice if we go into the game, this will break right here as well. Yep, so we got to change this method now as well. So what we're going to do here is we're just going to add a 32 by 32 box for now. This will be moved into the level class. We'll render the level instead of rendering the screen. But what we'll need to do is we will have a for loop. Int y is equal to 0, y is less than 32, just because we want a 32 by 32 box. Y plus plus. Copy that down, change it to x's, x, and put u. And then in here we're going to say screen.render. Now we want to render we want to render these tiles here. So we actually need to send in the actual positions of the tiles. So we're going to have to shift these over by 3, because shifting them by 3 actually multiplies it by 8. So that's going to give us the actual pixel value, so like the pixel value for where on the board it is. Similarly with y. And then we need the what's next? Next is the tile. So right now we only have one tile on the screen and it's 0. So that's this tile. So we're going to draw this tile. And now we need a color. So color.get, actually colors.get, and we need our 4 colors. So the dark color will make a white. So we're going to say 555 for white. What color? This color here. No, the black will be white. Sorry. This color here will make it like we'll make it that purpley color, so it will be 505. This color here, this light gray color, we will make it the opposite of that. Not really opposite, but 050. It's just a full blue color. And then actually, yeah, let's do that. We'll make that one red, this one blue, or this one green, sorry, and this one blue. The white blue. And we'll import our colors package. So now we have that, but it's still not going to render anything right now. So what we're going to do now is we actually have to copy the pixel data from the screen into the game. So we're going to do that. So it's going to be a for, it's going to be this loop again, kind of. So I'm just going to copy it because it's the basis of it. But instead of 32, it's going to be screen dot height and screen dot width. And then close those. Now we're just going to have an int color code, and that's going to be equal to screen.pixels and width times height, sorry, x times y, not width times height, x times y, or x plus y, sorry, times width, times screen.width. Because we want the screen's width, not the actual width of this. And then it's just going to be if, again, CC, or color code, is less than 255. Then we're going to say pixels at x plus y times width this time is equal to the colors, so that color array, at color code. So if we run this, you will see that if it works correctly, which it does, this screen pops up, which has set all the colors that we've asked it to set where we've asked them to set them. And we can click on the frame and scroll around here. It's going to do this because we're not rendering anything here. These pixels are empty now. Sorry about that. These pixels are empty now, so it's not actually it's gonna screw up with them. But you'll see that the actual game is correct here, and we will fix that kind of stuff later on when we limit the actual center, because the input is going to be based off the player later on. So when we limit the player to only walking along the bounds, and the screen will pause when you get to here-ish, somewhere around there, the screen will actually pause, and then your character will walk in this quadrant instead of this happening. But yeah, that's been a simple tutorial. We might actually start on the actual game level engine next episode. I'll probably do that. We'll render in some sprites, and yeah, so that's been your basic tutorial, and have a good day, guys.